Now it's time to talk about dimensional analysis, and this is going to be functionally the math that we are doing moving forward. Now, this is basically algebra with units. And you treat units like variables, they cancel with themselves but not with others, and you can convert from one unit to another using conversion factors. And so we use dimensional analysis to answer questions like, if I'm traveling down the highway at 65 miles per hour, how many meters per second am I going? If the speed of light is 3 times 10 to the 8th meters per second, what's the speed of light in miles per hour? If I have 47 kilograms of lead nitrate, how many moles do I have? You might not know what a mole is, don't worry about that. But basically, the idea is we have an amount or a value in one unit, and we want to know what does that equal in some other unit. Okay? And so to do that, we use what are called conversion factors. So conversion factors is functionally, and this is going to sound really weird, a logically true equivalence of two units. And you can kind of think of it as there are 3x and a y, or there are 5x per 2y. So let's think about this. There are 3 feet in 1 yard. There is 1 yard in 3 feet. So each conversion factor can be written forwards and backwards, because again, it is a logical equivalence. 3 feet is equal to 1 yard. 1 yard is equal to 3 feet by definition. We can also, and this is the more important part, set this up as a ratio. Okay, we can say that there are 3 feet per 1 yard, or that there is 1 yard per 3 feet. Okay, so because these are equal, right? Anything divided by itself is equal to 1. A conversion factor is functionally equal to 1. So you can put in a conversion factor into your equation, and it doesn't change the value of the equation. Okay? So the more frequent way we're going to use this is something like there are 1,000 meters in 1 kilometer. 1 meter is equal to 10 to the 9th nanometers. You can also say that 1 nanometer is 10 to the negative 9th meters. These are both true statements. Now, I generally will always write things out so that you have positive powers of 10, because I think it's just easier to work with. But you could use the 1 nanometer is equal to 10 to the minus 9th meters, and you will get the correct answer, assuming you punch in your calculation correctly. So these are all saying the same thing, but these conversion factors are what we use to basically do all the algebra we're going to be doing. So let's start with a simple conversion. Okay? And I want to know, if I've walked 10,000 feet, how many miles have I traveled? Well, the first thing I need to know, as Coach Boone would ask, how many feet are in a mile? 5,280. Now, I'm not going to make you pick the ball up and walk every last one of them, but this is our conversion factor. 1 mile is equal to 5,280 feet. Now, it does matter in what order do I put these, right? Because I could write this in 2 different ways, right? I can write this as 1 mile per 5,280 feet, but I could also write it as 5,280 feet per 1 mile, right? Now, because I'm converting from feet to miles, I'm going to want the feet on the bottom, so I have feet over feet, it'll cancel, and miles on the top. Okay, so I'll do 10,000 feet times 1 mile over 5,280 feet, so that feet cancels. Because otherwise, if I multiply by this, then I would end up with units of feet squared per mile, and that means nothing. This is one of the nice things about dimensional analysis, is that it tells you if you're wrong. It doesn't always tell you you're right, but it will tell you you're wrong. So if your units are wrong, your answer is wrong. If your units are right, then you probably got it right, assuming you punched in your calculation correctly. So feet cancel, and you get 1.8939 miles. Now here's where your significant figures would come in. So conversion factors don't have significant figures, right? They're functionally infinite. It's 1.0000 blah 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 miles per 5,280.00 blah 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 feet. So you don't, when you're looking at your conversion factors, even though it just says 1 mile, I could put 1.000000, right? So don't worry about the significant figures in your conversion factors. All that matters is in your initial value. So my initial value of 10,000, as I've written it, has 5 significant figures. So my answer can have 5 significant figures. So here's a practice problem. How many centimeters are in 2.53 kilometers? Pause the video and take a crack at that. So 1 centimeter is equal to 10 to the minus 2 meters. And 1 kilometer is equal to 10 to the positive 3 meters. Okay. Now, if you look, this is a difference of 10 to the 5th. Okay. Minus 2 to plus 3 is a difference of 5. So my equivalence is either 1 centimeter, not G. 1 centimeter is equal to 10 to the minus 5 kilometers, or 1 kilometer is equal to 10 to the 5th centimeters. Okay, so I'm going to say, all right, I got 1 centimeter. That looks like a 7. Let's try that again. 1 centimeter. Oh, sorry. I'm actually starting here. So this is one thing that just takes practice, is learning how to read the word problems, but a lot of times it asks you what you want first and then what you have second. So we're starting with 2.53 kilometers. And we want to convert to centimeters. So I'll put centimeters on top. So let's do 10 to the 5th centimeters per 1 kilometer. Kilometers cancel. And you'll get 253,000, or 2.353 times 10 to the 5th kilometers. Centimeters. I should put units there. Okay. If I have a block of lead with a volume of 45 centimeters cubed, how much does it weigh given lead's density of 11.3 grams per centimeter cubed? Okay. Don't be intimidated by the centimeters cubed. It's going to cancel just like anything else. So I'm starting with 45 centimeters cubed, and this is actually my conversion factor. So what this is telling me is that I have 11.3 grams is equal to 1 centimeter cubed for lead. If I have 1 centimeter cubed of lead, it will weigh 11.3 grams. So this density is technically a conversion factor, although you find it experimentally. So 45 centimeters cubed, and I'm going to multiply that by 11.3 grams per 1 centimeter cubed. Now, if there's no number here, then it's implied to be a 1. So if I were to write this the other way, right, I could say that it's 1 centimeter cubed per 11.3 grams. When would I want to do that? Well, you'd want to do that if I had the mass and I wanted to know how much volume did it take up, right? So I'm going to do 45 times 11.3, and you're going to get 508.5 grams. Oops, close my parentheses there. So if I started with this number and I said, okay, well, so I know the density of lead. What is the volume of this mass of lead? Then I could do 1 centimeter cubed per 11.3 grams, right? Grams would cancel, and you'd get 45 centimeters cubed, right? And then, of course, if I had the volume and the mass, I could say, well, I have 11.3 grams, I have 508.5 grams, and I have 45 centimeters cubed, right? I have grams over centimeters cubed, so my units is grams over centimeters cubed, right? These don't cancel with each other. So you simplify the numerical fraction, but this would stay the same, and you'd end up with 11.3 grams per centimeter cubed, right? So you can work this in any order. All right. A lot of times we're going to be doing longer conversions. And the best way to do this is to set it all up in one line. And again, if your units are wrong, your answer is wrong. So how many miles does light travel in a year if the speed of light is 3 times 10 to the 8th meters per second? Okay. So we're going to start with our initial value, 3 times 10 to the 8th meters per second. And let's start by converting meters to miles. So I'm going to multiply it by that equivalence, which is 1 mile per 1,609 meters. So meters will cancel. Then I'm going to want to convert seconds to minutes. So 60 seconds per 1 minute, because I have seconds on bottom. So seconds over seconds canceled. Then it's 60 minutes in 1 hour, so my minutes cancel. And then there's 24 hours in 1 day, so my hours cancel. And there's 365 days in 1 year, so my days cancel. And so now if you look, my units are going to be miles over years, which is what I was asked. Miles per year. Okay? Now, I can simplify this by all the tops divided by all the bottoms. So 3 times, this should be 10 to the 8th, 108, 3 times 10 to the 8th, times 1, times 60, times 60, times 24, times 365, divided by 1609, times 1, times 1, times 1, times 1. Now, you don't have to write out the ones, but, right? Miles per year. And you find that to be 5.88 times 10 to the 12th miles per year. And if you were to look up the value of a light year, that's pretty much on point, right? So we can calculate that out. So but you could do this in step by step. You could do, okay, let me first do, meters to miles, and then, okay, so that equals this. And then and then the next version that equals this. But if you put it up in one line, again, all of your units cancel properly, so your final units are miles per year. So that indicates, yay, we did it right. If you got something like seconds, if you got like meters squared over miles at some point, that means you did something wrong. Or if you got meters seconds over hours or something ridiculous like that, right? If your units are wrong, your answer is wrong. So here's a practice problem for you. If you have 0.0032 liters of a liquid, how many cubic decimeters cubed, do you have? So here are some conversion factors you'll need. 1 milliliter equals 1 centimeter cubed. 1 meter is 10 decimeters. 1 meter is 100 centimeters. So you can make these equivalent to each other, right? And simplify it. And then you need to cube the conversion factor. So remember, centimeters cubed is centimeters times centimeters times centimeters, okay? So if I were to multiply that by a conversion factor of, again, let's simplify this. If I were to multiply that by my conversion factor of 1 decimeter per 10 centimeters, only 1 centimeter is going to cancel. So my units would be 1 over 10 centimeters squared decimeters, which makes no sense. So I have to cube my conversion factor. So pause the video and see if you can get the right answer. All right, so let's work it out. So I have 0.0032 liters. We're going to multiply that by 1,000 or 10 to the third milliliters per 1 liter. Liters cancels. Multiply that by 1 centimeter cubed per 1 milliliter. Milliliters cancels. Multiply that by 1 decimeter per 10 centimeters. And I'm cubing this, so that centimeters cubed cancels. And I end up with decimeters cubed. And funnily enough, and this was not my intention, I made this. Sometimes when I make up problems, I get weird, the numbers end up coming out weird. This actually ends up being 0.0032 decimeters cubed. So, whoops, that was not intentional, but the math checks out. So we would report that as 3.2 times 10 to the minus third decimeters cubed. So that's just one thing to keep an eye on, is that if you have cubes or squares, then you have to do that to your conversion factors as well. So this is pretty much the only math you're going to be doing. Again, there's some logarithmic stuff, but that's pretty self-contained. So by and large, you're going to be doing these types of conversions. And this is about as long as they get. You're not going to be doing, generally speaking, too many more steps. When we look at stoichiometry, it's usually 3 or 4 different conversions in one line. It's pretty straightforward. It's grams to moles to grams, something like that. That's generally going to be the form of it. So if you can master this, then you're going to be set for pretty much all the math we're doing. And remember, if your units are wrong, your answer is wrong.